Okay, on to the next part of our genetic algorithm tutorial. In this part, I'm going to show you how to clone the lights based on a percentage you can define, and we're going to do that in a scriptable object. A scriptable object is part of your assets folder, and that has the advantage that when you change values, it's going to be stored in the assets, and it's not going to be like here when you say in the inspector, you might change things. But actually say, you know what, I want that light spawner component somewhere else, and values can get lost. The scriptable object doesn't have that. It's always going to be the same. And the much bigger advantage is actually that you can reference the scriptable object from one point, change the values, and then you can reference it from another point and read those values. And the one that's changing those values and the one that's reading those values, they don't have to even know that the other one exists, and then you have nicely decoupled code, and that's good practice. So let's just say create C# script. Now we're going to make the template basically, which is just a script. So call this one mutation stats and open it up. To turn it into a scriptable object, just change one behavior to scriptable object. And so we can easily create it in the editor. Just use the attribute create asset menu. And you can even go further and define submenus or special names, but usually you can just keep it like that. So there should be a typo, mutation stats. And this one is going to have a float. Mutation range in percent. And an integer called mutation multi, which is going to tell us how often we're going to clone each light that is going to be picked in here. And another typo, mutation range. Okay, so just save it. First of all, let's correct the typo. Mutation stats. And now we can just say right click, create add mutation stats. So that is our scriptable object, and just name it mutation stats. And in here we can say mutation range and percent. For now, let's keep it at 50%. And we're going to clone each light one time. Okay, now that we have that, let's go into our cloner. And first things first, in the last video I said we need to initialize the list. That's not really true, because this line is going to give us a new list, which is going to initialize it. So we don't have to make a new list. You can just delete that line. And in here we are going to get a reference to the mutation stat we just created. Just say private mutation stats mutation stat. And that means you can now drag in there any scriptable object that you created based on that template. So let's say gate cloner mutation stat. And what I said earlier about the decoupling, for example, you now might have a slider in your interface that changes those values, like I have in my game. And then that slider, all it does is it has reference exactly like the cloner to that and changes the values, and it doesn't even have to know about the cloner, that the cloner is reading it. Okay, so let's make a function to clone the lights. We're going to call this one private void clone lights. And in here we're going to have a local list of light. And this one's going to be called cloned lights. And let's instantiate that to a new list, like so. Now the idea is we're always going to take the first one from our new generation, which is going to be the best one, and then we're going to remove it from that list. and add it to the cloned lights list. And then we're also going to take the last one, the last item of our new generation list, knowing that is the worst one, and we're going to override it so that becomes the clone of the one we just took off. And eventually, in the end, the new generation list is going to be pretty empty, and the cloned lights list is going to have all the lights we want. So the end of that function, we're just going to say new generation equals cloned lights. And then we're also going to account for what happens when we have some lights left on the new generation. But first things first, let's turn our mutation stat clone range into an integer so we can loop through our new generation list. And for that, we're just going to say mathf round to int. Now we're going to take that mutation stat dot mutation range in percent divided by 100 and multiply it with the count of our new generation list. So new generation dot count, and one more bracket. That should work. So in our case, we had the mutation range in percent is 50 divided by 100 is 0.5 multiplied by 100, because right now we're spawning 100 lights, it's going to be 50, and that's exactly the number we want. Now we're going to make a for loop, and in here we're going to run it as many times as we have lights to clone. And as I said before, we're now going to take the first item of our list, and we're going to store that in a local variable called original. That is going to be new generation dot 0. And now we're going to remove that from that list, like so. And we're also going to add it to the cloned lights list. Okay. And now we can actually use a new feature of C#7, which is a local function. And we're going to call this void clone light. Not with an S as in here, but just in here. And it's going to take in a light, which is going to be the original light. We're going to call this one by saying clone light. We pass in the original, like so. And now we have our other stat in the mutation stat, which is the multi. So now we're just going to make a while loop, and we're going to say while. Oh, sorry. First of all, we're going to store the mutation stat, the mutation multi, in a local integer, and we're going to say it clones left equals mutation stat dot mutation multi, and then we can say while clones left is bigger than 0. And very important, we also have to check that we have enough list left on our new enough lights left on our new generation list. So we're going to say new, and that is not and, that one is new generation dot count is bigger than 0. And what's going to happen is here we're going to clone the light, and before we forget it, of course, we have to say clones left -1. And once again, we're going to make a local variable light clone, and we're going to take the worst item of our new generation list, and we're simply going to do that by saying new generation item new generation count -1, and that is our clone, which now has to be overwritten. And to do that, we have to make two functions in our light movement. And in here, as you might remember, our path is private, and we want to keep it that way, but we want a way to access it. So we're going to make a function that is going to return a path called getPath, and it's simply going to return the path. And now we also want to override it. Override path, and that one is asking for a path that it can apply. And so vector2, call this one new path. And now we're just going to say path equals new list vector2, and we're going to copy in the values that we just received. Okay, those two little functions are all we need right now. So our lights are able to be cloned. And in here, we pass in the original, which we just took off the list. And now we're going to clone it by saying clone.movement.override path, and then we're going to ask the original light for its path. Once again, we have to go through movement, get path, like so. And just like with the original light, we have to remove it from our new generation list. So let's say new generation dot remove clone and add it to our cloned lights list. Cloned lights dot add new generation. No, add clone. That's better. Okay. One more thing you may have noticed is we might actually clone it so that in here, eventually we're going to take off the last item of our new generation list. Then that loop is done, but we're still running through this loop, and we might not have anything. New generation 0 might not even exist if the list is empty. And so we should make sure that if nothing is on there, if new generation dot count equals 0, we're going to break out of this loop. And when we break out of this, or we are done with here, then we're going to say new generation equals cloned lights. And one more thing you may have noticed, that we are not necessarily getting all the lights off our new generation list. So we should say cloned lights dot add range, and we're just going to add whatever's left on the new generation. So at this point, we're making sure we get everything, and then we can say new generation equals to cloned lights list. And now, of course, which I always forget, we actually have to call that function, clone lights. And I think this should work, so save the script, go into Unity, and let's hit play. Or actually, check the mutation stats. We're cloning 50%. We're going to clone that one time each. And so what you're going to see now is that half the lights are going to become clones of the top 50%, and they're going to be cloned exactly, so they're going to be overlapping, and therefore you're only going to see half the lights. Every one, it's gonna go half. And in the end, you have the lights left that took the best path. And just to try it out that our mutation multi-works, let's say 10 times. Actually, that's too many. Let's say 20% going to be cloned 5 times. So that should happen. That sorting should be a lot more drastic right now. And yeah, you can see right away. And the overlapping. And now there's only going to be 1 left. Okay, that's it for now. In the next video, we're going to mutate the lights. And of course, we're going to use that mutation stat scriptable object. So we can add some stuff and see by how many percent we want to mutate each waypoint. Yeah, that's pretty much it. I hope you enjoyed it. Any questions, criticism, just leave a comment. Then see you next time.